Have you ever wondered why the simplest objects around you are packed with surprising engineering tricks? Today, we're breaking down 15 everyday items that hide brilliant design choices, invisible mechanics, and tiny details you've probably never noticed. Let's start. The strain relief bump on USB-C cables. That soft rubber bump near your charging cable isn't just decoration. It's called strain relief, and it absorbs the bending force that would normally snap the copper wires inside. Engineers tested thousands of bends. With strain relief, cables last up to 8x longer. Why power bricks are so big? Inside your charger is a tiny transformer that converts dangerous wall electricity into safe, low-voltage power for your phone. Transformers need space to avoid overheating. And that's why even modern chargers are chunky. They're literally saving your device from exploding. The scissor mechanism under keyboard keys. Under each laptop key is a tiny scissor-shaped plastic frame. This design distributes pressure evenly, prevents keys from wobbling, and snaps back instantly when you lift your finger. A single key has more engineering than early computers. The microvent holes on AirPods. Those tiny dots on AirPods aren't microphones. They're pressure balancing vents. Without them, air pressure would build up in your ear canal, making the bass muddy and the fit uncomfortable. The vents keep sound natural and stop your ears from popping. Why Wi-Fi routers have angled antennas? Wi-Fi isn't just sent into the air. Antennas create donut-shaped signal patterns. One vertical antenna spreads signal horizontally. A tilted one covers upstairs and downstairs. A router's strange look is actually 3D signal engineering. The hidden camera inside your mouse. Your mouse isn't tracking movement with a ball. It uses a tiny infrared camera that takes up to 10,000 pictures per second. It compares each frame to the next to calculate microscopic motion. Your hand moves, and the sensor sees the world slide under it. The polarized layer on your phone screen. Your phone is covered with a polarizing filter that only lets light waves from one direction pass through. This improves contrast, visibility in sunlight, and makes screen reflections disappear. Tilt your phone sideways. You'll see the polarization effect instantly. The metal mesh on microwave doors. The door isn't glass, it's a Faraday shield. Microwave radiation can't pass through the metal grid because the holes are smaller than the wavelength. Light can pass through so you can watch your food spin. Safe and visible at the same time. The double seal inside bottle caps. Unscrew a plastic bottle cap, and you'll see two sealing rings. One seals the top of the bottle. The other seals the side walls. Together they stop pressure from leaking and keep carbonation fresh for months. Why washing machine doors are curved? That bubble-shaped glass isn't for style. The outward curve redirects spinning water toward the steel drum instead of the door. Flat glass would crack. Curved glass turns water pressure into structural strength. Why salt shakers have different hole sizes? Salt pours faster than pepper, so manufacturers made salt holes bigger, and pepper holes smaller to balance the pouring speed. It's simple physics disguised as kitchen trivia. The layers inside magnetic stripes. A credit card's black stripe is not just ink. It's 3 layers of iron oxide magnetic film. Each layer stores encoded data like bank ID, card number, security tracks, transaction protocols. It's basically a tiny magnetic hard drive. The capacitive grid under touchpads. Touchpads use a web of invisible electrodes that sense changes in electrical charge when your finger approaches. Your finger doesn't press, it creates a tiny distortion in the electric field, and the pad tracks that movement in real time. The rotating metal plate inside staplers. At the bottom of every stapler is a rotating anvil plate. Turn it around and you switch modes. Inward bend, permanent staple. Outward bend, temporary staple you can remove easily. Almost nobody knows this feature exists. The objects around us look simple, but they're full of invisible engineering that shapes our everyday lives. If you want a part 2, or want me to break down any of these in extreme detail, let me know in the comments. See you in the next video.